Hey guys, welcome to lesson 3, Regents Chemistry, Separation of Mixtures. We're going to recognize various techniques that we can use to separate matter. All right, let's go on to our note packet and page 9. Let me open that up for us. And that's what it should look like right here. Separation of matter. The first one is probably the easiest one, maybe one you've seen before. It's filtration. You see the beaker of the mixture that we're separating, filter paper with a funnel, and then as it runs through the filter paper, you get a filtrate that's done. The idea is what kind of changes that you can separate. Two things. It's physical. Oops, sorry about that. Physical. I don't know what I was thinking. Physical. And the idea that you have to be able to write or recognize is that the filtrate passes through some sort of filter and the undissolved particles. Whoa. I actually write neater than this. Sorry about the translation. Undissolved particles. There's a special name for undissolved particles that are in solution. They're called solids. And they remain are caught by the filter. So they're caught by the filter. And it's just, I think the one that I think is the easiest way to separate. It's a great way to separate like the Italian dressing. And if you recall, Italian dressing and others are called heterogeneous mixtures. It is the only type of substance, I should say matter, that you can use filter paper for, because it just has to have at least more than one phase, all right, present. So for example, separating sand from water. You can separate the sand by using filter. This one's a clever one. You'll notice we have a crucible. We'll have a Bunsen burner, low flame, an evaporating dish, and a watch glass that goes over it, but there's a little place for vapor to come out. You'll also know a different way to do it is just by crucibles. Crucible with a lid, a clay triangle that holds it nice and steady. Both of these are advantageous in some ways. When you set these up in your lab, make sure you're careful because these will be very hot. How do we going to separate? Well, since we're evaporating, we're simply vaporizing something. That's called a physical change. So there's no tricky thing there. The other thing is it's a way to separate a solute from a solvent. I'll explain that in a second. Separate solute from solvent. All right, what's the difference? Well, the solvent is what dissolves some sort of matter like salt into a solution, and the solute is what you add to that thing, the solvent. So in this case, if you add a beaker and you add a solvent, let's say water, and you wanted to add salt to it, that salt that you add into it is called the solute, and the solvent is the water because it's dissolving it. What's happening during this process? You'll see this steam vapor. Well, that's when the solvent evaporates. And only the solute remains. It's limited precision. For example, it's one of the first ways we learned how to make seawater, ocean water, into fresh drinking water. That's why if you're on a deserted island and you need to drink some water, it's better by far to drink the water that has been evaporated into rain and precipitates out than it would be to drink the seawater. This is good to separate homogeneous substances like salt water, because a homogeneous substance looks the same throughout, so you can't actually tell there's a difference in the salt water than regular water, but it separates homogeneous mixture. Now, and the things I've been describing right now, homogeneous mixtures, they're called solutions. So once you mix a solute into a solvent, you get a solution back. All right, let's move on. Here's a really cool way to do something. It's called distillation. Notice that you got some salt water here. And unlike the last time, this vapor that's coming out from the heat of that solution is not going to the air. We're going to capture now what's coming off. So that vapor comes into this tube. It's going around in this direction. And it's hot vapor, right? So we add this really cool, we have them in the lab. You'll see them. This cool jacket of cold water with an inner tube of hot vapor that we're just coming in right in here. And that cold water cools off that vapor. And what happens to vapors that cool off? Well, they go back into liquid phase and they drip out as, in this case, pure water like I described. So this is also a physical change. You can certainly make everything go back. You need two different liquids. So this is a way to separate them. So if you are having two liquids like alcohol and water mixed together and you want to separate them, you just need to use a distillation process. So separate two or more liquids. What if it was a solid? Remember the filter? That's what we'd use. It's very important that they have different boiling points. I'm going to really work on this writing. And what else? Both solute and solvent are captured. So it's a no loss. So you can see that everything is accounted for at the end. It's a closed system. You're not losing anything. And that's it. Chromatography. This is a really interesting one you've done, I believe, or will do if you haven't already taken biology. I think you all did. You have a solution here, and there's different chemicals inside of the solution that you want to separate. Oh, hey guys. And you'll have a physical change by moving those chemicals across things, and so the particles will be separate based on their properties. Particles will separate based on properties. I sometimes think I should type this out. Maybe I will in the future, especially when there's so much tight writing. Okay, well you'll know that the smaller ones will move up faster, and the larger ones will move up slower. And you also know that the ones that are more easily dissolved will stay in solution. The ones that are less easily dissolved will go up the piece of paper. So solubility is also a way to separate things this way. This is a really clever technique. It's more recent. It's a good way to separate solutions that look exactly the same. Okay, you could also have chemical separators, and we'll talk a lot about that this year. So we'll learn about the fundamentals, how to separate things chemical, and chemical separation requires you know about chemicals. So that's what we're learning in chemistry. It requires reacting with a sample and something else in order to turn into a a totally different compound. And that concludes our notes today. Your homework, let me just pull that up, is in the practice packet, just like you'd expect. Here we go. And there's all this reading. So what do you do with it? Because some of you will be intimidated by the vast majority. I do encourage you to read it. Maybe skim through it, highlight some key ideas. More importantly, use this as a resource to flip back to answer these questions. So what separation technique would be used to separate a mixture of two colorless liquids? Well, we know the answer from our notes, but you also can just use this as a handy recall tool, I guess, to answer this. So if you just have your practice packet, you should be able to answer these questions. I really want to help you with one of these. Let me just tackle one random one. What type of separation cannot be used to separate the components of a homogeneous mixture? All right, so one thing you don't want to do is use, for example, filtration. Because there's no solids in a homogeneous mixture. All right, so that's an example of one. All right, guys, good luck on your homework. Thanks for listening.